Hello friends, welcome to the second session, and today I'm going to teach you some real programming, and I'll also give an example of the program. I hope you remember the buzzer which I told you in the earlier session. Okay, so buzzer is controlled by port C, pin 3. Okay, so first I need to show you the microcontroller, the motherboard. So this is the motherboard. This, where my pointer is the buzzer. These are the switches. This is the microcontroller. This is the microcontroller where the programming will be done. This IC here, this IC controls the motors, and the motors will be connected here. Okay, this switch turns on or off the motor. This switch is whether the motor will take internal power or external power. This switch decides whether the program has to be embedded or not. And this switch controls the battery, that is the power which is given to the microcontroller. The battery is connected here. This is for the logic system, that is LS. Here the battery is connected for the microcontroller, and here the battery is connected for the motors, that is the driver system. This IC here controls the input and output from the computer, that is from the system, and this is the port where you will be connecting the USB. So this was your microcontroller. So first I'm going to teach you that how to make a makefile. A makefile is something which helps to know that what is the version of the microcontroller, and the type of programming you will be doing on it, because there are many type of programmings which you can do, like MATLAB also is used. I'll be teaching you MATLAB later on, but for now we stick to C++. So how do you make a makefile? Okay, first I've provided the softwares in the software section. You can download it from there, and then just go to all programs. If you are using Windows 7, you will see an option which is written WinAVR 200700525. Just click on it, click on mfile, that is WinAVR. Okay, when you click on it, you'll get this. Okay, so you have to make some changes. Go to the makefile option, change the MCU type to ATmega. Since I'm using ATmega 16, I'll do it ATmega 16. You might be using some other kind of ATmega version, like ATmega 8535, that is 8. Then you would have to select ATmega 8. Okay, this is mainly for AVR only. This is only for AVR. The output format will be iHex, since we are using hex code. No need to change the optimization level or debug format. You need to set the C standard to GNU99. Okay, and then you would have to click on enable editing of makefile. Okay, what you would have to do is this. Okay, this, since you can see this is the frequency of the clock, which is set to 8 megahertz. But since the microcontroller which I'm using is having a clock of frequency 16 megahertz, I'm going to set it to 16. Okay, so just do the required changes. And one more thing which is very important, the main file name, you need to set it to main. Okay, just set it to main, because all the files of C which you will be creating will be stored in a new folder. Each file has to be stored in a new folder, because when you do a make file, it will create n number of files which would be stored in that folder. So you can't have all the files in just one folder. You have to create a separate folder for each program you make. Okay, so just save this make file. We'll save it, and remember that each C code has to be named as main.c, since the main file here is named as main actually. Okay, so we'll just save it, save as, makefile. Okay, it has to be saved as makefile. I've already created a folder which is named as my first program. I'll save it there. Okay, I'm saving it here. So it is saved. Any other time you make a new program or a new folder, you just need to copy this file. You need not make a make file again and again. Just copy it and paste it to that folder. That's enough. Okay, so we'll close it now. Okay, now you need to do is open the WinAVR console. That is this one. This one. You can see here it is written programmer's notepad. This is the WinAVR console, and this is where we'll be programming. Okay, so when you'll open it, it will look like this. I've already written a program to make the buzzer buzz. So what we do is, as you must be remembering this, first we need to include a file, and for this we need avr/io.h. Okay, then int main void. Okay, now the main programming is here. I've set port C is equals to 0x00. Why 0x00? As I told you earlier, that a 0 is used for resetting the system. So first we'll be resetting the system, then we'll be setting the system. I hope you understand. And then we are having this DDRC. Okay, DDRC is nothing but just the way the buzzer will react. Will it give an output or will it take an input? Okay, so it is giving an output, therefore I've set it to 0x08. You need not reset it or set it. Only the port settings are resetted or set it. Okay, then I've initialized an infinite loop using while with 1 inside the brackets, and then I've written port C equals to 0x08. Now I have set it the port C and especially the pin number 3 to 1. So as you'll be remembering that for port C and pin number 3 to be set on 1, we have this coding 0000 1000. I just got a request that some children did not understood how come this 0000 and 1000 is 08. Okay, I just want them to listen carefully. Okay, so actually what happens is, first we divide this into two parts. We are using 8 bits of coding, so just divide it into two parts. Okay, we'll divide it into two parts, and then okay, so this is your first nibble 7654, and this is your second nibble 3210. Okay, so 7654 is having 0000. Okay, so the hex code for 4 times 0 is 0, so we are having a 0 for this 7654, and then for 3210 it is 1000. So what is the hex code for 1000? As we can see, the hex code for 1000 is 8. Okay, so we set it to 8. So this is 08 in hex. So as you will be remembering, I told you earlier that we have to write 0x if we are writing a hex code. So 0x means that the numbers after 0x will be in hex. So 0x08, that means 08 is in hex. We can't write 8 bits binary code again and again. That is why we are using hex code. So now the programming is done. This is the main program for running just a buzzer. Okay, now what we'll do is we'll save it. We'll save it as main.c. Okay, remember main.c because in the make file we have named the main file as main. Just go to the folder which you had created earlier. That is my first program for me. I save it and then just go to tools and click on make all. Remember, make all. After clicking on make all, you'll get an output. Okay, the process exit code has to be 0. Otherwise, that means you have an error in your coding and it will not work. So, okay, I told you earlier that you need to create separate folders for this. And why? I'll show you. Look, the number of files it created. So these many files will be created every time you make a particular C++ file. So now what do we have to do? Launch this HID boot flash as I told you earlier. So if when you launch the HID boot flash, you'll get this menu. Okay. You first need to connect the device, that is the motherboard, to the PC, and then click on find device. After you click on find device, it has to show you this till the device size. It will show you till this device size 0001638 For you it might be different because depending upon the size of your memory. Okay, go to open.hex file, select the file which you have created already. Okay, now open.hex file means that the file which you will be selecting is main.hex, which has been made by make all. Okay, open.hex file is done. Then click on flash device. After you click on flash device, you will get these three lines. You'll get these three lines, and you have to make sure that it shows finish flashing the device. Otherwise, it won't work. Okay. So after you have done all this, I need to show you this video. Okay. So first, what I have done is I've set the programming button to on. That is, it has to take the program from the system. I'm embedding the program onto the microcontroller. Set it to on and then set the power to on too. After you set the power to on, you'll see this light. I hope you are able to see this clearly. You'll see this light. Then click on flash device. Okay. Once you're over with the flashing, set the programming button to off. Okay. Once you set the programming button to off, you'll hear a sound like this. This is the buzzer. Okay. So this was your session for today. I hope you liked it. I'll definitely teach you how to make a line follower and a smoke detector and much more. Maybe a maze follower too. Thank you.